Yeah, I'm
We don't
good.
need the-
Can you
okay.
guys hear me?
Yeah.
All right. Can I get the clicker?
Yes, sir. There you go.
All righty. Let's see. All right, we're going to start with a teaser. I'm going to give you 2 words. I'm going to ask you a quick question, and I don't need you to answer in your head without thinking, okay? The 2 words are lucky dwarf, and think of the number between 1 and 10. How many of you thought of number 7? Just raise your hand. Anybody want to guess why that is? No? Well, yeah, kind of. So the trick here is that basically I'm playing and basically priming your system 1 thinking. Natural language processing and these large language models basically operate and are imitating our system 1 thinking. Like this is when you basically just quickly surface things. What I did is I basically primed your system by asking you about, telling you about the lucky dwarf, and your association in your head is 7, lucky number 7, 7 dwarfs. That's the first thing on top of your head. When I push fast question, things like this happen. This is basically what happens behind the scenes in large language models. These things and numbers basically are what we call embedding, and they get stored in something that's called vector databases. So speaking of these things, I'm going to kind of use some of that as a background. We're going to talk about 3 primary things. So counter to that MIT study, I'll speak about what I see with the customers. So my job at AWS is basically I'm responsible for the architectures of all of the customers globally for an organization called AGS, which is commercial. So that's thousands and thousands of customers. Part of the team that's called Cloud and AI Innovation. So a lot of discussions and a lot of the pushbacks and things like that are about how do I actually make money off of this thing, right? Is everybody making money? No, but there are those that are. We'll spend quite a bit of time about agentic, and we'll talk about how is that actually being implemented. There's actually real use cases that you're probably interacting in your daily lives today. You just don't see it. We'll talk about the concepts of agentic. Your and mine are not different, actually. It's pretty similar. And then we'll talk a little bit about the future. But before we start talking about the future, if you're asking yourself, is this real? So I'll give you some data points. This is already outdated. This is an investment, capital investment by the cloud providers. It's about 392 million, okay? AWS itself already is over 100 billion. Last week, NVIDIA invested 100 billion into the OpenAI. 2 weeks prior, Oracle and OpenAI invested 300 billion. This morning, JP Morgan announced we're going all AI in, 1.3 billion spent last year. So the question is not whether this is here. The question is how you're adopting and how you're driving the value out of it. There are 3 basically primary use cases that we see in adoption of the customers, going top to the bottom. So turnkey agentic solutions would be basically very similar to what Kurt was explaining. You adopt the Fexa solution, it's basically turnkey solution. That's what majority of the customers that I talk to actually do. Whether it is from Fexa or other partners of AWS, that's really what most of them do. Custom agent development, that's really independent software vendors. Some of the companies do this. And then the bottom part is folks like AWS, Azure, et cetera. This is where you basically get at the infrastructure level and basically burning all of that energy to answer, give me a funny joke. So the 2 things that are kind of at top of mind for all of the executives I talk to, so I do a lot of board presentations, and security and data is always number 1 and 2. Is this secure? How is it secure? Does this hallucinate and things like that? So what you're seeing here is basically some of the questions and implementation underlying technology that needs to be in place is how do I know the identity of the person that has done this? Going back to the Kurtz, is this ever going to make a management decisions? Maybe, maybe not, because identity can be represented. If this is your coworker, it will have identity maybe in the future. therefore it might have a similar authority, therefore it might make these suggestions. The other part of this is how do I know what things have happened, right? So logging and things like that, making sure everything is secure, being able to not do the things like I did you at the beginning, right? Not prime you to basically give me wrong answer, hallucination. There's a whole area called automated reasoning, which basically validates the claims and basically comes with binary result. Yes, this is true or false. That's kind of how you avoid hallucinations. If you basically play with any of these tools today, you'll find out that they do not hallucinate as much as they have. The data is on top of everyone's mind. The key things around the data is it actually expands from normal data understanding. Like we used to understand the data as a databases, then data lakes. Now it's unstructured data. The visual data is becoming more and more popular. It's still not there. The visual is only used in like autonomous car driving. But a lot of our learning as humans come actually through the eyesight, not actually through the comprehension, reading interactions. These models are still heavy text, heavy audio, but the vision is actually coming in as well. The key point here is that most of the customers that I talk to, they're actually reorganizing their data. They're doing different things around the data. That 80% is probably more like 90%. Gartner says it's 80%, but every customer that I talk to is finding the data that they had, PDF that was sometimes stored a long time ago for the insurance companies, for example, and now they're basically deriving the data out of it. This is just another example if you're familiar with Robinhood. So this is a perfect example. Robinhood basically has like 25 million customers. They're probably one of the fastest growing brokerages. They build a product called Cortex. And basically, if you look at here, security in the customer data is the imperative. So this is actually already in Robinhood application. This is dealing with financial data, giving the advice and standardizing it. So if you're asking yourself, is it safe, is it secure, maybe ask Robinhood. The 4 primary use cases are basically in this realm right now. Kurt spoke probably about each one of those. So improve workplace productivity, that's kind of like a back office stuff. Bringing agility and scale to the process. How do I do things faster, better? I'll give you kind of some of the examples of these, and then accelerating research and innovation is primarily in healthcare and pharma. This is basically where the models are doing hypothesis. I'll show you an example in financial services where you can actually do the accelerate research and innovation. And I'm sure there's cases in your industry that you can do the same things. And then quality and resilience of the overall solutions. So one of the examples, and this basically goes back to the Kirk's point. I forgot what the percentage of the employees onboarding is. It was like 20 to 1 or something like that. So in this example, this is NFL implemented something basically for the newly hires. These hires are basically production assistants. They cycle really quickly. They have a very hard job of basically gathering large amounts of data to basically answer some simple questions. In some cases, it takes them like 24 hours to go through all of that. So what they have done, they basically implemented Gen AI tools, and that now takes about 10 minutes to get an answer. So it also helps with training that new employee. So basically retention, acquisition, and by the time they're ready to do some serious work, basically just gets improved. So this is just one example. It can be applied to anything else. If you think about in your industry, maybe a technician that has never done HVAC X can just basically ask some questions about it, and based on those answers, can quickly basically determine and troubleshoot. So let's talk about agentic and AI agents. So I'm going to give you just a little story. Just think of the agentic as a travel agent. So all of you know what the travel agents are probably. You already spoke with agents on the phone. That's what agentic means, actually. So it's basically mimicking the behavior of travel agent. So for example, when ChatGPT first came out, you could ask a question like, how do I get to London? And it might say, take the flight to New York. From New York, transfer to the flight to London. Take the bus X, and so on and so forth. but it could have not done anything else. It's just basically, it's a question response. With agents, basically now these models are starting to use the tools and other agents to basically orchestrate these things. So in a nutshell, if you think about agentic, what it does, it starts to do some level of reasoning. So at the beginning, I told you about system one level thinking, like that's where you think really fast, that's what we all do. When you're in the deep thinking, that's called system two level thinking. That's really where the agents and reasoning starts to come in. If you have played with any models, you find out that some of them actually can reason now. And the way they reason is very similar to this thing. You give it some sort of an input. In this case, I'm giving it work order, needs an issue. Basically breaks that down. That's what the plan means. So what should I do? When something is broken, what are the things that I do? Identifies those steps. When it takes those steps, acts on each one of those steps. The acting might mean do more research, call another tool, or call another agent, and basically spins that in a loop. And once it actually finishes the reasoning, it provides output or the outcome. That's basically what the agents do. To correlate that so enterprises really like this because there's two key things to kind of differentiate LLMs and agents. In age of large language models, like at the very initial stage of this, you needed to have a PhD level scientist to actually build your own model. Let's put it this way, nobody is building their own models anymore unless you are an Amazon, OpenAI, Google, etc. Agents themselves are more like a distributed computing and API at the next level, in a nutshell. So what Kurt was referencing is the next level of the evolvement of the compute and things like that. That's really manifesting itself in agents. To show you the example, not sure if you're familiar with Bridgewater. Bridgewater is about 50-year-old hedge fund, one of the largest ones in the world. Last year, they managed about $140 billion in assets. So they are in a league with Citadel, for example, and things like that. They actually have the platform, and they implemented something called AIA, A-I-A. They call it AIA, which is intended to help their researchers basically do their work faster. The concept that Kurt was referring earlier, I call it an exoskeleton. So basically, it's augmenting the human. Those researchers are all PhDs from Harvard, MIT, etc. And what they do, they basically create hypotheses, which is like an economic projection, and then they run hypotheses against the old market data, and the hypothesis is either success or failure, and then they do the investments. So this kind of shows you some of these things. You can basically see that this is very applicable even in some of your use cases, because you have basically a planner, you have a supervisor, synthesizer, data finder. In their case, they have a coder. You may not have the coder, you might. But what they're able now to do is basically augment the work of those researchers and answer the questions like the ones on above. And using the data, they have about 50 years worth of data. Using the data, they basically create hypotheses, and then they basically test the hypothesis. So AI is giving them new ways to hypothesize about the possibilities and things, how to make and not lose money. The whole thing, this is basically, if you ever talk about the expert systems, this is basically breaking down the expert system into its constituent parts and executing it through the agents. I'll be a little bit more blunt. I think there will be agents that actually manage people eventually. The field is developing rapidly. This is going to be 28, 29, 30. I have no idea. It might take another 20 years. For those of you that don't know, this did not start in 2023. It started in 1957. Okay? A fellow named Chomsky basically conceptualized this. In 2013 is when the godfather of all of this thing, Jeffrey Hinton, basically sold his company to GCP. So it's been 60, 70 years as this has been progressing. It's been up and down. Some of the breakthroughs basically got us to this thing. So thinking about these things, the multi-model, multi-agent systems basically going to look something like this. So I try to kind of correlate this to you. So if you look at this, I'm basically I encounter a problem. I start the work order. I try to collect required data. I chose assets if known. I upload some images. I will submit the work order. And I have a basically breakdown. Do I need FM to approve? And I provide the dispatch. Provider performs the work. Invoice submitted. Approved, reject, and exported. Looks familiar to anybody? What if? What if I could do something like this? This is totally doable today. I think during the demo you might see some of these things. But as you can see, I'm basically using the old workflow, and I'm just basically adding and augmenting to some of those cases. Some of the steps, like the first step, I can start work order. I can have a tool that basically starts work order and just basically creates that entry. I might have a tool that basically collects required data, all of it or some of it, right? I can ping the HVAC itself if it has some sort of if it has a capability to basically answer and basically give me diagnostics. I might be able just to ping it and get data, so on and so forth. So there's a numerous, this is just one of the if things. This is intended to kind of have you start thinking about stuff, how to do these things. Now these are the three kind of like very common use cases across all of these industries. Not all of these might be applicable to your industry, but automating routine tasks and documentation is like everyday gravy for the current technologies, okay? It's super easy. It can be done at multiple levels. I spoke with a customer yesterday that publishes large amount of information, and they're like, how do we know that this is still accurate? And we actually built something that reads all of this information and then checks it against the public sources as well as their own newly product launches, and basically says, these things have changed, you need to update these things. So it basically keeps stuff up to date. Saving the thousands of hours annually in data analysis and reporting, there's probably every business intelligence tool now has a capability instead of, how many of you know what the SQL is? Have you have to do the SQL? Okay, only a few of you. SQL is the language you basically interact with the database, and it was only privileged to the quote-unquote technology folks who knew the SQL. Now, you can go in and say, how are my store number 1 and 5 doing this quarter? That gets translated to SQL, gets sent to the database. Database returns the result, and you basically get answer in a natural language, right? So it opens up the doors for everyone. So these are the kind of like common steps that most of the customers take. Go for it, 5 minutes, okay. I'm running ahead of time, actually. So define your high use cases. Kurt mentioned this as well. Make sure that your use cases have return on value. What I do with the customers a lot when they say we want to do something, I run them to something called DVF, Desirability, Viability, and Feasibility Framework. If you never use it, super easy. It basically gives you quickly answers whether this is a fairly good idea or terrible idea. You can do many things with this technology. The question is, should you? One of the examples I can give you, like in the early days, I was talking to one of the tech execs in insurance company, and he wanted to do automation of the claim processing. At that time, it was still pretty expensive to do some of these things with these models. And used to, like when we did the high-level analysis, it was about $120,000 a month just for the models itself to run and things like that. And they were paying about $80,000 for the offshore resources to do the same work. So is it doable? Yes. Should you pay 120 versus 80? I say you just pay the resources until the things become cheaper. Some of the things in these technologies are still fairly expensive. You all heard about NVIDIA, GPUs, TPUs, all of those things. They just keep getting cheaper, cheaper, and cheaper. Anybody likes Jeopardy? All right. Remember in 2013, Jeopardy, IBM Big Blue basically beat the crap out of humans in Jeopardy? It was doing basically same things that we've been talking about. And the question is why we haven't started in 2013. There's a number of the reasons. One of them is accessibility of the hardware and ability to make it cost effective. So when it comes to defining your use cases, just make sure it's cost effective. Otherwise, you're going to end up in MIT report with the failure rates. Align on a clear business outcomes and success metrics. This goes back to that insurance claim. I mean, unless you know what these are, I guess don't start. And then this says engaging stakeholders. Stakeholders might be your employees. It is one of the big mistakes to hide these things because your own employees might be afraid for their jobs and things like that. There's no way to, unless you're going to replace every employee, which currently is not feasible. This is really augmentation technology right now. Engaging them early, making sure that there's a feedback. One of the biggest things that's challenging in adoptions of Gen AI and AI agents as your coworkers is the fact that they have zero personality. They just don't behave. They cannot do the small talk. They cannot do the water cooler talk. If you play with some of these things, example of this is Grok. If you go to Grok, so word of caution, Grok is not necessarily the most curated model, but if you go, you'll see that the models actually have a personality. And the research basically that's being done shows in order for these agents to be accepted as our coworkers, they need to be with more personality, they need to behave like us and be able to do a bunch of things that we kind of do. And then launch with one team commitment to value delivery. This is kind of where the relationship comes with the folks like Fexa. If the things are already done and if you can basically get them off the shelf, I would say that's better, easier way to adopt it versus actually trying to do your own. If you do your own, make sure you have expertise to actually do so. With that, I'm going to close it up. If you have any questions, I'll be around, or who's next?
Yep. Thanks, Tarik. Are you going to stick around?
I will be around, yeah.